Okay, today we are gonna talk about first Delta PLC family. Then we will talk about the feature of AR series. After that one, we will have some hands-on. I prepared some demo kit for you, so we will have some hands-on together, and then we will share few success stories with AS series, and it will be the end. Okay, so around 2 hours we will be together. Okay, first thing, Delta PLC roadmap. So over here you can see, let me open my pointer as well. Yeah, over here you can see the timeline and the functionality of the PLC that produced by Delta. Okay, the first PLC Delta released was 1999. And the first PLC in the world was around 1970s. We can say that we kind of jump in the middle of the PLC life. And in a short time, I can say that we grow rapidly. As you can see, we have many series, and still we are, as a Delta, we are investing on PLC families. Okay, so here you can see we have long-term plans. Okay, what we have so far? So far we have DVP series. This is our basic PLC series, and it is the first PLC we released, and still improving. And it is cost effective, and when you compare the performance and functions, it can meet low-end and some high-end machine or OEM request. And then we released AH series, which is mainly focused on process automation, and it is modular design and hot swap redundancy safety functionalities there are. And here you can see that at the back there is a back plane. So it is modular, but with a back plane. And then as a last, we released AS series. So AS series also like AH series, it is modular design. There is a variety of network. So it supports many network communications, industrial network communications. We will see details. And also there are some, let's say, advanced motion control, but mainly for CANopen and pulse and analog. Okay, and also we will release EtherCAT as well, and also support distributed remote I/O solution. Okay, so this is what we have as a PLC product family. Okay, we have many series, and each family has their own sub-series, so it sometimes can be difficult to choose the right PLC for the right application. So here you can see the overview. First of all, depends on I/O size actually. So if you have more than 1K I/O points, then you have to go through AH series. If you have less than 512 I/O, then you can go through DVP series. But then you need to consider the PLC project capacity. So it is difficult to know in advance that how many kilo step program you will write. But still you can guess more or less, you can have some idea. So let's say that you have less than 256 I/O points, but your program capacity is more than 16 kilo step. So then you have to go through DVP advanced series or AS series, okay? So this is the overview of the PLC types. And after that, most of our PLC are the modular type. So it means that, okay, there is a power supply, CPU, but yeah, I/O can be customized, depends on your project. So here we have many modules. Here, for instance, for the IOS, digital and analog IOS we have. And there are versions like mix IO, only input, only output IOS. Or we have communication modules like Modbus serial or DeviceNet CANopen Profibus, or Ethernet-based Modbus TCP Ethernet IP Profinet. Also, we support remote I/O solution. We will see detail about it. And we have, CANopen Ethernet IP, and in the future Profinet as well. So according to function, we have also temperature controller and motion controller module and load cell module for the weight control. Okay, so it depends on the application. You can customize your PLC set. Okay, so first we say that we will focus on the AS series, and AS series have AS300 and 200, two different model. Okay, so over here on the screen you see the AS300. There is a built-in I/O which supports pulse output, hardware interrupt, high-speed counter, and digital input-output. There is the Ethernet port which supports Modbus TCP and Ethernet IP. And also, if you're familiar, we have a data exchange table, so you can exchange data between third-party devices or another Delta PLC with that table easily. And we cannot see over here, but at the bottom there is a RS485 port for the serial communication. We have a function card slot. It is empty slot, so it can be customizable. So you can add a serial or can open Ethernet IP Profinet card over there or analog I/O. Depends on your demand. Okay. And over there is a mini USB as well, and dip switch for the run and stop mode. Okay. And also AS series supports micro SD card for backup, restore, and protection. And also you can log your error code or receipt in the SD card as well. So this is overview of the AS300. How about 200? 200 also same. There is a built-in I/O which supports pulse output, hardware interrupt, high-speed counter, and digital input-output. There is the Ethernet port again. And at the bottom there is RS485. There is a mini USB for programming, supports micro SD like AS300. This is different. So for AS200, there is no function card slot, okay? But there is embedded can open. So yeah, for the AS300, if you would like to use can open, you would like to get function card. But AS200, it is embedded. Okay, let's have a look to AS300 CPU specifications. So program capacity is 128 kilosteps. So it is around one step, we can say that around 4 bytes. So it's around 512 kilobytes. And execution speed for ladder is 25 nanoseconds. So one contact execution speed is 25 nanoseconds. And this module AS300 supports up to 1024 points or 32 modules. Okay. And yeah, we talk about the SD card, Ethernet IP, so I skip this part. So over here you can see the which models we have. According to output type, there are different models. There is a MPN output type, there is a PNP output type, there is a differential output type. And there is a no built-in digital input output module as shown over here. So it is just the CPU. And yeah, there is a MPN and PNP output, but pushing connector. So here you can see the MIL connector. It's called MIL connectors. And this is pushing plus technology. Okay. And AS200, this one has a 64 kilosteps. So again, if you multiply by 4, so it is around 256 kilobyte. But the execution speed same like AS300, 25 nanosecond. Maximum I/O point and maximum expansion module is the same, 1024 points or up to 32 modules. And again, according to output type, there is an MPN, PNP or relay type, or there are additional module for this one, which has a built-in analog input output. So for the small applications, instead of getting an analog module, these module already have a built-in analog input and output. Okay. So this is the AS200. Yes, AS300 is a high performance CPU, and you can see some values over here. For a contact execution, we said that already 25 nanosecond. And for the move instruction, for instance, it is 0.15 microsecond only. So think about that. There is a PLC project consists of contacts and move instructions, around 40 kilosteps. and the execution time for this user project is 1 millisecond only. Okay, so when you compare the DVP series, yeah, the execution speed is quite high. Okay, let's have a look at the key features for the AS series. So we mentioned that AS series supports remote I/O solution. For the DVP series, it was same that there was a remote I/O solution as well. But for that one, we need an additional software, DCI soft. But here, AS200 for the CanOpen and also for the Ethernet Type, we don't need additional tool software. It can be done in the hardware config directly. Ethernet IP will be the same. CanOpen, it's like this as shown here. Ethernet IP will be the same. So today we have demo for remote I/O as well. So we will demonstrate CanOpen. We have quite intense content today. I will pass these specifications quickly. Then we will jump onto the hands-on. Okay. So we say that SD card is supported by AS series. So the advantage is that, let's say that you're a machine builder, you shipped your machine somewhere in another country. If you need to change or if you need to copy the machine over there and you don't want to share the user project, can be, there is a know-how maybe inside. So you just simply get the backup file to SD card and ship to the SD card customer, and they cannot get the file from the SD card, but they can copy from one PLC to the another. Okay. And in addition, there is another advantage for the AS series is no need battery for the permanent data backup. If you need the variables that you need to store inside the PLC, then you don't need a battery. PLC has a permanent data backup. Battery is needed only for the real-time clock applications, okay, for the RTC applications. So if you don't need to use real-time clock functionalities, then you don't need additional battery for AS series. Okay, another point is that easy to install. So as you can see, we say that it is modular type CPU, and it can be mounted DIN rail, so no need backplane or nothing. And in order to get one module out, so you don't need to discrete all the modules, so you just get one of them separately. And for installing it is the same, so you just need to push and click, that's all. And also, when you compare the size, it's quite compact. So as you can see, it is just 88 millimeter. So it provides you more space in the electrical cabinet for you. And here you can see for the high density I/O, like 32 or 64, we use mil connector. Okay, and for the other modules like 8, 16. Then it is better to use push-in technology. So here, yeah, you don't need any connector or any conversion cable, no. You just push-in plug. But for the high-density I/O, 6432, then the wiring is not easy. So yeah, it is better to use additional conversion connector and the cable. It is mil connector. And for 8 and 16, we have EU connector, screwless and fast connector. Okay, next thing I would like to highlight is industrial network. AS series has built-in Ethernet port VSET, and this Ethernet port supports Modbus TCP and Ethernet IP. Okay, and also supports email, web functionality, web monitoring, SMTP email functionality, IP filter, and also supports flexible topology as shown here. For the Ethernet IP, for the field devices, you can also prefer Ethernet IP. So we have an Ethernet IP builder software tool. Okay, so you can communicate with Delta products with Ethernet IP or third-party devices, even manage switches. And AS series can be client and scanner. It's kind of master and slave. And maximum connection number is 32, and capacity is per package is 500 bytes. And update time is 1 CPU scan only. Okay, another module belongs to communication is AS00SCM. 00SCM is kind of function card slot. So over here, you can customize your communication. So after you get the SCM, you can mount F232 for RS232 or 485 can open or Ethernet IP. Okay, so Ethernet IP is already built in, but yeah, we said that up to 32 device support. So if you have more than, or you would like to work as a adapter version, you would like to be a slave for the other network devices, then you can use AS FEN02 as well. Okay, we will talk about, but another advantage of the SCM module is for the remote I/O solution. So we say that we support remote I/O solution. What is remote I/O solution? Actually, we have a CPU, okay, and we have some input and outputs far from the PLC. And let's say that you have 10 digital input over there. Instead of cabling from the far digital input output to the PLC, you are simply using SCM module with can open or Ethernet IP, and then put the I/O card nearby, okay? And then wire your sensors over there, and then get all the digital input values via communication to the CPU. So you don't need to get another CPU over there, or you don't need to make wiring more, okay? So SCM module is just a communication card, we can think. So remote I/O solution, for the remote I/O solution, we need SCM. So we will demonstrate it. Okay, middleware. What is middleware? We have a PLC, it is hardware, and we have a software, ISP soft, okay? So those two needs to talk each other as well. So for this, we have COM manager, okay? So COM manager allows you to connect CPU, okay? So you have a software, ISP soft. So over here, you can see ISP soft, and you have a COM manager. It also works on Windows, we will see. So you have drivers. So it allows you to connect from software to the hardware, okay? Okay, before go to the hardware configuration, so if you like, we can make some hands-on to see how the COM manager works. From our download center, when you download the COM manager, this is the interface. So you can create your driver here. So here, in order to create new one, you need to click add and give a specific name. So for instance, I call training. And here you can choose the connection type. Okay, so here we have an Ethernet, and then you have to choose your Ethernet card of the PC. So for my PC, my Ethernet connection card is this one, and you can see the IP address of the PC. And when I click the search, so COM manager searching network devices that connected to PC and brings the connectable devices over here. So right here, you can see that we have AS218px and the IP address is 1.5. So COM manager works based on MAC address. So even the IP address are not in the same level, can be found, but doesn't mean that possible to connect. In order to connect to device, the PC IP address and the device itself has to be in the same domain, okay? So up to 1, it has to be same, only the last digit has to be different, okay? So this is how it looks like. So you give a specific name, you choose the type, you choose the Ethernet card, you can add manually over here, or you can search, okay? And yeah, there are also some additional setups, but yeah, it's good to use default most of the time. But for instance, if you would like to use via internet or something, sometimes it is good to increase the timeout. For the local host, local host, it is more than okay. But for the remote connections, maybe it can be less, okay? Just keep in mind. So when we create, so over here, you can see that the name and the connection and the status, okay? So it is ready right now. So in order to connect via software, we need the COM manager, okay? We have to adjust driver first. Okay. please let me know if you have any questions or if I'm going so fast, just let me know. So we will talk about it. So next thing after the COM manager, next thing is the hardware configuration. So we said that AS series is the modular type, right? There is a CPU, there are different modules. So yeah, depends on the application. Every customer has a different type of modules, type of configuration. So when you are programming the PLC, your PLC project needs to know which hardware devices you have, which modules you have. Okay. So for this, we use hardware configuration tool. Okay. So it is a graphical user interface as shown here. So you can just simply drag and drop. Okay, so you can see the IO table to set the settings of the modules. So you don't need to use from to instruction in order to adjust the modules. And it is possible to go through to another software from the from the hardware config. Okay, so hardware config is the tool to adjust the modules we have nearby the CPU. Okay, before remote IO solution, let me demonstrate that one as well. So hardware configuration, how to go to hardware configuration, but first have a look to ISP soft. So for PLC programming, we use ISP soft. Okay, so when you open the ISP soft, it is the interface. So you can go to over here to create a new project. Okay, so give a specific name. Okay, and then choose the controller type. So here you can see which controller we have and ISP soft supports. Okay, right now we have AS and PLC type is 218PX. Okay, and this is the path that store the project. There is a properties here. So here you can give some details about the project, like program title, company, designer, and some explanation comments about the project. If you are planning to print out the project on a paper, then it's good to fill those parts because those are also printed on the paper. So if you don't fill, then it will be just empty area. So but for test, no need. But if you are planning to print it out, then it's good to keep the title, designer, and some comments. Okay. So we give a specific name and we choose the controller type and click the OK. Then ISP Soft creates a new project for us. And here on the left-hand side, you can see the project tree. Okay. Let me open it a bit. Yeah, on the type, there is a quick tools and there is a menu over here. At the bottom, you can see the status of the CPU. Right now, it is offline. And this is the driver name in COM manager we created. This is the CPU you created in the project. And this is the capacity of the PLC. So right now, there is a 65,000 steps and none of them used right now. Okay. So here we will go through all, but I just want to start with hardware config because we talked about it already. So when I double click the hardware config, or actually, yeah, before that one, it's good to show how to assign COM manager and ISP soft. Okay, let me show that one first. Okay, so we say that first we need a COM manager driver, right? But as a project, don't know which driver we use. So first we have to assign which driver we have in order to connect PLC. So over here inside the tools, there is a communication settings. Okay. And here you have to choose driver for this project. So just creating driver in the COM manager is not enough to connect to PLC. So you have to choose the right driver here as well. So yeah, we created that my training, and the IP address of the PLC is this one, and click OK. So over here at the bottom, you can see that the name of the driver, my training. Okay. So it means that this project used this driver in order to connect PLC. Okay, we choose that one, but still we are not sure it is accessible or not. So the easiest way to check if it is connection is established or not is go to the PLC and check the system information. If you can see this page, then it means that there is a connection between software and the hardware, because this information comes from PLC inside. Okay, so here you can see the version, firmware version of the CPU, MAC address, program capacity, there is a password or not, and the execution time, scan time of the PLC. So yeah, after choose the right driver over here, please check the system information if there is connection or not. So right now for us, we can connect to the PLC. Okay. Then next thing after adjust this one is the hardware config, because before start to PLC, we have to define which modules we have in the software side as well. Then we can use those address in the PLC project. So yeah, in the hardware config, we can adjust the setting of the CPU and module, and yeah, IP address, communication settings, all those kind of settings are done in the hardware config. So it's opened. So this is the overview of the hardware config. So here you can see that there is a PLC, and over here you can see a plus sign. So when I click, I can assign. Okay, I can add manually like this. Or here there is a product list. So here you can enable or disable. Okay, so let me enable that one. So here you can choose your modules manually as well. Okay, so let me choose, for instance, analog module. So this is how we did manually. So over here you can see the CPU name, addresses. We will explain them a bit later. So let's start with the CPU. When you double click CPU, then you will see that the setting of the CPU. Over here there's a description, there is a DDF version, and there is an exchange area. So here you can see which address you have, and you can adjust the communication COM port 1 settings and COM port 2 Ethernet port. You can change the IP address over here, or you can use advanced Ethernet port functionalities like socket programming or email functionality. And this module AS200 has a built-in analog input output, so you can set the analog input output settings over here. Okay, voltage, current, whatever, and you can adjust the CAN-open communication here. So these are all belongs to CPU, and like CPU, it's also same for the modules as well. So let's double click to another module. So here you can see what settings we have for this module. So for instance, there is a format. So how do you want to use this analog module, as an integer format or float format? Or there is a setting like you want to use 0.10 volt or 0.20 milliamp. So yeah, with a few clicks, you can adjust all those settings. You can also control those settings inside the user project, but then you need to use from to instructions. Okay, so those kind of settings most of time adjust before the project, and then we use same settings. But can be maybe sometimes you want to control those settings, enable, disable some analog input outputs from the user project. Then you need to use instruction like from to instructions. Okay, so yeah, this is how hardware config works. So here you can upload all the settings from CPU, or you can download. And there is also scan function. So in order to define the modules, you don't need to do it manually. So you can scan the network directly. So CPU software will bring all the modules you have in the hardware to the software. Okay. And in the online mode, you can check the status of the modules. Let's click the online mode, for instance. So yeah, over here, yeah, you can see there is a crossbar over here. The detected module is different from the configuration. So it means that, yeah, okay, you defined in software, but in hardware there is no such a module. Okay, so you can check the status of the module here as well. Okay, so it is more or less how hardware config works. So after you complete all the settings, you have to download and save the project. Okay, we talk about hardware config as well. Remote I/O solution. So I mentioned about it. Remote I/O solution. We have some solution with CANopen and Ethernet IP. So this is the idea. You have a CPU in the electrical cabinet, and you have some input/output analog I/O. I don't know, whatever. Like say that around 100 meters away from the cabinet, and you have mini analog sensors over there. So instead of cabling all the 100 meters to the electrical cabinet, or instead of getting another CPU for the remote I/Os, you can get SCM and CANopen option card or Ethernet IP option card, and then mount the digital input output or analog input output nearby. Okay, and you can connect up to 15 slate. So you can connect like this, and then this SCM module read and write the I/O status and send to the CPU. So it allows you to control 100 meter away physical input output from the PLC directly. Okay, so we have two solutions, CANopen and Ethernet IP, and it supports up to 15 slaves and up to 32 modules. Okay. So before go to the programming software, let me demonstrate remote I/O as well. Let me share. Okay, so this is my demo today. So I prepared this one for you. So over here you can see on the left hand side CPU. Okay. No, sorry. So this is power supply, and then CPU, and then built-in analog input output, digital input output, and then we have a analog module 06XA. Okay, and then we have a junction box for for CANopen, and we have SCM module and CANopen function card, and we have another digital module as a remote I/O. For the CANopen, we say that the connection is at the bottom for the AS200, and it is built-in, right? We carry all the wiring over here, this junction box, and then it is possible to use RJ45 connector afterwards. Okay, so this is a junction box for CANopen, and then this is remote I/O. So we can jump one to another. And for the CANopen, you have to wire termination resistor as well. Okay, so that's why there is a resistor here. Okay, so this is the hardware setup I have here. So in the blue cable I will use for connection, I would use USB or serial, but I prefer Ethernet for this one. Okay, so I have here in the power supply, here you can see the 24 volt output, 24 volt output. So this red and black is for 24 volt output, and some modules needs additional power supply. Okay, so for instance, this analog card needs additional 24 volts power supply. So that's why I wired this one. And also this SCM module can be supplied by 24 volt DC. Okay. So this is the setup I have right now. And yes, we will make the remote IO solution first, and then we will talk about software detailing. Okay, after explain the setup I have here, let me turn back to software. Okay, so hopefully you can see the hardware config right now. So how to adjust remote IO solution in the hardware config? So you have to double click on the CPU, and here there is a built-in CAN communication. Okay, so go to the built-in CAN communication, and here there is a work mode for CAN port. Okay, and it can work as remote communication, or Delta special driver and remote mode, or standard can open DS301, or special driver and can open DS301. What is special driver? Special driver is a kind of protocol, let's say, used can open indeed for Delta servo and VFD drives. Okay, so you don't need to use DS301 for Delta devices, for ASTA A2, for instance, or or VFD devices. So you can simply use special driver to control. Okay, thank you for the question. We have one question. Is there a specific order to follow when adding IOS, e.g. analog first or communicate? No, no, it is feel free. No, you don't have to follow any rule or nothing. So yeah, you can go one by one, doesn't matter. Okay, so it depends on you. Okay, thank you for the question. As I said, feel free. Maybe I'm going so fast because yeah, it is online training, so I cannot see the feedback directly. So feel free to interrupt me. So we will talk about more. Okay, I'll keep going otherwise. We say that can open work mode. So here we will use remote communication. And for the can open, you have to set the bit rate. Okay. So for the bit rate, I already set 1000K. So I choose this one. Let me show you how to choose that one as well. Here you see SCM module has 4 rotary switch. Okay, so it is turnable. So this is ID1 and format 1, and these are for the option 1. Okay, but for the can open, you don't use the option 1. So I set them 0. Okay, and last 2 for the option 2, and it is can open right now. Okay, so let me show you over here. So ID is the can open node address. Okay, so can open node address. Each node has to have a unique number, and format is the place that we define the baud rate or bit rate of the can open. So it is right now adjusted as 7. So 7 means that 1000K. Okay. Okay, there is another question. Does distance affect the speed baud rate of? Yes. When you choose 1000K, for instance, if I'm not wrong, it is 25 meter. But if you choose less than 1000K, like, I don't know, I guess it's sequential. If you choose 5K, then it is 50 meter. If you choose 125, it's 100 meter or something. So yeah, depends on your bit rate. The distance changes. Yes, you are right. Yeah. So right now in office, I have just, yeah, it is nearby, so I can use 1000K. But if the distance is more than 25 meter, then I couldn't use. Okay. Okay. Let me keep going. I explained how I defined 1000K distance. So let me share the hardware config again. Yes. Okay, so that's why I choose 1000K here. And here, the number of the module. So here is the part that how many module can open remote IO module you have. For instance, if I say 5, And let's close this one. See, hardware config already defined for you that 5 different I/O, and like previous time, you can adjust them manually like this. Okay, so that's the idea. Or I can go over here, so we can set. So yeah, it can be up to 15. So you can use up to 15 module, but don't forget that in total module you have can be up to 32. Okay, so you have to consider module number up to 15, IO module remote IO number, let's say 15, module number is 32, and IO point is 1024. Okay, so yeah, let's say that you have, I don't know, 15 IO module, it's okay, but in total it is more than 1024, then you cannot use. Okay, so there are limits, please consider them as well. So yeah, as you see, you can do it manually, or as we talked before, you can scan directly to the hardware config. So when I click to scan, okay, CPU is here and analog module is here, and we have also remote IO, but didn't bring. Let me check what can be the reason. So here is 1000K. Okay, and then let me upload inside what we have in, I don't know. Okay, that's the wrong part. So then we have to, yeah, okay. In order to scan, the CAN bit also has to be same. So I will download first. Okay. And this. So here you can see that after you click the download, asking you which parameters you would like to download. Okay, so yeah, if you haven't changed anything in the Ethernet Basic or Advanced, you don't need to download. Okay, but I just as a habit download everything. So let me scan it again. Okay, again it brings the analog module which is mounted to the CPU but not the remote IO. Let me check. Okay, CAN communication. Yes. So when you scan, but again, in order to scan the CAN network, because this hardware config only scan the IOS, okay? But here, if you would like to scan also the CAN network, then the baud rate has to be same, right? So first, you have to adjust the baud rate and download the setting over there. Then hardware config can scan. Otherwise, yeah, there is no communication. So right now, it brought that also the remote IO. So this is CPU, and there is an analog IO here mounted, and there is a SCM and CAN open card, and there is a one digital output here. Okay, you can see over here. So this is the address. So now it is possible for us to use this module as a inside the PLC project. Okay, so it is how remote IO solution works. Hopefully it was clear for you. If you have any question, let me know. Otherwise, I will jump to the another topic. Yes, we have another question. Is 100 meters the maximum distance between the CPU and all modules, or between the modules? Between the modules. Yes, between the modules is 100 meters. Okay. So let me share my screen again so it will be clear. Okay, I guess you can see the presentation. Yes, between modules is the 100 meter. Okay, thank you for the question. So I'll keep going. So next topic is the programming software, ISP soft. So yeah, we already see how to create a project and yeah, how to assign driver from COM manager to software. So, but let's see the interface. So, you know, there are different way of programming for the PLCs, and the common PLC programming languages are LD, SD, CFC, and SFC. And ISP soft supports all of them and can be used in the same project. Okay. In the same project, you can use different programming languages. Not written here, but like, I don't know, previous update. Now ISP soft also supports C programming language. Okay. So if you have a C language user project already, then you can directly import to the ISP soft. Okay, so we can say that 5 languages. ISP soft is modular structure. So it is one of the advantage. But in order to understand the advantage of the modular structure, first we have to understand what was the conventional way before. So traditional PLC programming was like that. So there was a main program at the top, and then there was an interrupt program afterwards, and then there was a sub-programs. Okay, so think about like Notepad. You open that one page and typing all the codes here. So for the debugging or also during the programming, it is not user friendly at all. So right now, ISP soft supports modular type. What does it mean, modular type? So you can create different programs and different function blocks. Okay, so program, function block, function, those are described in the standard PLC open standard IEC 61131, if I'm not wrong. Yeah. So these are defined by standard, and ISP soft also follow those standards. Okay, so you can create a different program and you can create different function block. So you can call function block inside the program, and you can protect your PLC project completely, or you can protect just one function block. Okay, and here you can see the program section, function block section, and here inside the program also written the type. PRG means the type. Let me choose the pointer again. Yeah, program or function block type, and then the language. How did you program? Ladder, SFC, ST, ladder, ST. Okay. And also the good thing is the task manager. Again, let's turn back to the traditional one. For the traditional one, it was like, okay, you are writing your codes inside one project, and the PLC starts to execute from beginning to the end, okay, and line by line, okay, command by command. And yeah, let's say that during the programming, you type some codes over here, but then you decided that it is good that if program 3 executed before than program 1, then what you need to do, go to the inside the project, find the code, use it start, and cut it, come over here at the top, paste it. So you also think about the order, execution of the order of the CPU, but you have to handle it by yourself. But here in the ISP soft, we have a task manager, okay? And here inside the task manager, you can define the execution time of the program, okay? So here, for instance, we have a cyclic task, okay? It means that, okay, it started to task and execute it, and then if it is done, and then start again, okay? It's freewheeling. And here you can see the order, execution order. So first, this PLC project execute the program 0 and then program 1. And here there is a cyclic task 1 comes from 0. So this is the another order. So then program 2, and then turn back to the 0 again. So here you can say that, okay, first execute 0, then 1, then 2. So you can change the order directly inside the task manager. I will show you. And we have another task. We will also talk about them, but like time interruption or hardware interruption. Okay. So all those settings, execution settings, can be done inside the tasks. Okay. So this is another advantage of the ASP.soft. Yes, here we talk about the protection. So there are many ways of the protection for the PLC program. Here you can see that there are 5 different protection methods for ASP.soft. So first of all, you can protect a POU program or function block, and you can limit the retry times. You can protect the PLC to upload. You can protect your user project to upload from another software. So you can protect the PLC with PLC ID protection, and also there is a memory IC protection. Okay, so here you can see an example. You set an ID for the PLC program and the PLC hardware. Okay, so yeah, you have a program and you have a PLC, and they have a unique code. If they are not matched, then it is not possible to download this program to the software, to the PLC, to the hardware. So let's say that you have a program and the PLC, but yeah, getting another PLC from another place, then not possible to copy this, to download this program to do this PLC. Okay, so it allows you also to provide PLC for your customer. Okay, and you will be sure that PLC bought from you. And another topic is IC duplication prohibited. It means that, okay, you download a program to the PLC, right? And the project is on the higher layer, let's say. But on the below layer, there's a IC over here. Okay, so for some PLCs, it is possible directly copy the PLC project from one to another. But yeah, we can assure you that it is not possible for the Delta PLC. It is not possible to copy, duplicate from the lower layers as well. Okay, so yeah, protection is an important topic for us as well, because we have to make sure that we also save our customers' know-how. Okay. Okay, another topic is IO using, but before IO using, let's have a look to ASP.soft. So here you can see the ASP.soft. Here we says that on the left-hand side, there's a project tree. And we will talk about them, but we talk about hardware config. Card utilities for SD card. So for memory backup and etc. And let's start with the programs. Here is the place that we create our program. So in order to create new one, you have to right click to new, and then give a specific name. For instance, I don't know, starter, just the name. And it is default active, but sometimes it is also possible that you create a project just for test, or maybe you will enable it later, so you can disable. It means that this program you created will not execute it by PLC. So here you can protect them by password or none. Here the place that you choose the language, so LD, SFC, SD. So here you can see actually ASP.soft supports more languages, but AS series does not support instruction list, for instance. Okay, so that's why it's gray. So these are the languages that you can use inside the AS series. And you have a specific command that mission starter. Okay, and here you can assign the cyclic task or another task. Okay, so I clicked OK, and then ASP.soft prepare the area that we write the code. Okay, so here, this is the place that we write the code. And when we create the project with the ladder diagram, so you can see there is another toolbar over here for the ladder programming. So let me create another one, and yeah, let's call program 0, doesn't matter, and let's start this one ST. So here you can see the differences of the programming area. So this is, for instance, here is the contact. You get the contact, you put it over here, you give an address. Okay, so then you go over here, you put a output, then you give a address, and for the ST, the bar is different. See, so also the place is different. So this is for ST. Let me add another one, then I'll show you the task. So let's call it program 1, not a problem, and ladder diagram is fine. So yeah, here I have 3 tasks, 3 program. Okay, starter 0 and 1. So the execution time for each program is defined inside the task over here. So all defined inside the cyclic task 0, the highest priority. So first these 3 will be executed. Okay, and inside this task, first starter, then program 0, program 1. In order to adjust sequence, double click, and then here you can see that, okay, task 0 is active, and these are the assigned POUs. Okay, so you can simply choose the program 0, for instance, and then move it higher or lower. Okay, or you can take this one out, unassigned. Okay, so it means that this one, you can see there is a red cross over here. This is not be executed. So I again double click. Okay, and then I come to over here and see, you can see the unassigned POUs. So I choose that one and assign to cyclic task 1. So first PLC execute to cyclic task 0, and which is starter first and program 1 second, and then go to the cyclic task 1 and execute this one, and then turn back to the starter program. So this is the freewheeling execution. Okay, so there are another task as well, but no assigned POU, so yeah, it will not execute it. Okay, another task method is that external input interruption. External input interruption means that, let's say that, okay, let's assign a program 1 to here. Okay, I assign program 1 to external input interruption 0. It means that, okay, program 1 during the cyclic time, it will not be executed because it is not in the cyclic task. Okay, so there is a condition here actually. So this program waits for the condition, which is, for this case, x0.0 falling trigger. So this program execute only if x0.0 falling trigger there is. Okay, and it executed 1 only. So for some application, especially for the cutting application, you have to be sure that there shouldn't be any delay. Okay, we are talking about execution time, which is milliseconds more or less. It seems like not a high, but still for some applications, even 1 millisecond is too late. Okay, so you have to be sure that for, especially as I said, cutting applications, you have to sure that when you receive a digital signal in the PLC, you have to start the cutting process. So then you have to use external input interruption. So yeah, as I said, it's kind of condition, waiting this condition, and when it happens, it execute once, and then turn back to the site task 0. So let's say that it was inside the starter and executing the starter, but not finished. Okay, so still inside the starter. And then x0.0 digital input, there is a signal over there. PLC directly jump to the program 1 and execute program 1 and finish the program 1. Then what's gonna happen? Then PLC turn back to the task 0, starter, not from beginning, the place it stayed before. So just keep going from the same spot, okay? So this is the cyclic task and external input interruption. We have a question, I guess. Yeah. Is it possible to assign external interrupt input condition to a different input, or they are all predefined? They are all predefined, so you cannot change, but the list is quite long, so you can see you can use all of them. So you just need to define which port you want to use. Input port, yeah, 4, 12, okay. So it is all defined. You just need to come over here and assign which IO you would like to use. Okay, hopefully it was the answer of the question. Okay, then another task type is hardware high-speed compare interrupt. High-speed compare interrupt is also another important topic for execution, because as it says that it is high speed, so it is let's say that there is a motor turning and there is an encoder mounted there, and motor is turning, can be conveyor for instance, and then encoder generate pulse and you wire encoder to the PLC, okay, to catch the speed for instance or the position. So yeah, it's going really fast, and let's say again for the cutting application, so the conveyor is rotating, right? So, and there is a one position you have to compare and cut over there immediately. So for those comparison, if you use internal comparison blocks instructions, then there should be some delay because of the execution time. Okay, so for instance, it just execute the comparison in the PLC project, and then to the next comparison, there is let's say the 2 millisecond can be late. So for the especially high speed applications, it is important to use interrupt task to execute. Okay, so over here again, it is condition. So it is comparing the hardware high speed counter, and if the condition is occurred, then execute the program. Okay, so yeah, there is a software high speed compare. The difference is that software is slower than the hardware, and there is a communication interruption, external interruption, so high speed output completion interruption. So there are different type of task managers. Okay, so you can control the execution time of the PLC of the program. Okay, it was a thing I would like to highlight. So we talk about the task, we talk about the programs, and the function blocks are the codes that can be reused again and again. So for some cases, let's say that for the factorial calculation in the math, right? So for instance, for the factorial, it is just a command that sometimes you need to use, not always. Okay, so what you need to do each time if you need to use factorial, then you need to write it again and again, right? But if you create a function block and then write your own code over there once, then you can just call the function block and it works once and give the result to you. So it allows you to, if you need to write the same code again and again, it helps you to reduce the code amount. Yeah. Okay. So let's go to another topic. We have some questions. Is it possible to assign external interrupt input? Yeah, we talk about it. Do you have any programming example in ST and C language to share? Show. Is there any manual or instruction code list for SC program? C programming. Okay. Yeah, for the ST we can make an example over here. No problem. For C language, for C language, we adjust you to use external program to create your own code and then import to C program, because over here there is a, for instance, let me create a here program C language. Yeah, here you can write your own code, okay, but the compile is not it is not a C compiler indeed, right? So for the C, I suggest you to use another C compiler. Write your own code over there, compile it, make sure that it works, and then import to the ISP soft. Then everything will be fine. But yeah, you can also create your own code on here. But I'm not an expert of the C language, so for me it is a bit difficult. So most of the time I prefer to use another compiler and then write the code and then import over here. Okay, so here also you can see the C resources. Okay, and then right click and then import. Then you will be sure that the code you import will work. For the C, I don't have example. But yeah, we can create one and then share afterwards. Let me okay. Okay, I'll share with you, Ronald. Yeah. For the ST, we will make some example over here. Okay, thank you for the question. So let me turn back to, no, not this one. Yes, we talk about this. Yeah, IO using. Yeah, before understand the IO using, we need to understand the memory area of the PLC. So here, there are some memory area in the PLC, as shown here on the left-hand side, like data register, D area, W area, M area, SM area, counter area. So these are the internal memory area inside the PLC. So yeah, it is good to compare with the software programming, then it will be easier for us to understand. For instance, for the software programming for the C, for instance, or C++, what we are doing actually, we are defining the data type, integer, and the variable name, I, and the value, okay? And this variable is stored somewhere inside the PC, right? And we don't care about which memory is used because it is kind of limitless. So, but PLC, not possible. We have a limited area, and we work with the physical devices, like analog values, like like digital input-output signals. So we have to think about the memory as well. So here inside the PLC program, we have some memory areas. Okay, so this is the input relay. X memory is the input relay. Okay, and it used as a bits. So X0 is the channel name, X0, X1, X2 is the channel name, and that 0, 1, 2, 3 is the member, kind of member, okay? So for instance, we have a PLC right now, which has a built-in PLC, built-in I/O. So first input of the PLC is 0.0. Second input, 0.1, okay? So for the output, we use Y channel, Y 0.0, 0.2, etc. So for the word, it can be used as a bit as well. But for the word, we use D memory and the W memory. Okay, and this is also M area also bit memory. So this is only bit. So it is internal, not a physical assignment. No, it is just internal auxiliary input. So like software programming, what we need to do, we need to use the address. But in that case, you don't need to define the data type because D100 is the word area and the data type is word already. So you just need to use D100, but then you have to think about, you have to keep this address in your mind that you use D100, okay? Or you can also use variable for the PLC programming as well, which is also getting popular and popular. But still, in that case, you have to consider which address you use. Okay, otherwise can be conflicts. Okay, for instance, you have a variable I, and you say that okay, I assign to D100. So anymore, when you call the I variable, it is stored in D100, and then I is equal 3 means that you store value 3 inside the D100 memory. Okay. So that's why these addresses are important. These are the address that we are going to use inside the PLC projects. So this is from the PLC user manual. So you have check. You can check over there. So simply again, for the word array, we use simply D, input, output, physical relays, X for input, Y for output, and for auxiliary bit area. For timer, we use T area, T0, T1, T2. And for counter or high-speed counter, we use C or HC. Okay, and some of the areas can be used as a word, as a word or as a bit. Okay, so after understood this part, let's jump to the input-output memory. Okay, here you can see an example. Actually, we say that there is a I/O memory inside the PLC, and this is kind of table that PLC store the values inside and checking in each cycle. Okay, so this is, for instance, X0, channel X0. If you remember, there were 16 bits for one word. So here there is a table and there is an output table, there is a D memory. So it is just storing table values over here. And there is an input unit and output unit, right? So here, and there is a code you wrote inside the PLC. So here there is a condition 0.0. If this is enabled, then there is an output 0.3. Okay, so PLC is executing this code constantly. So checking 0.0, if there is output, no output. How to check? Actually going over there and checking the status. And this status also controlled by the input unit. So when you push the button, the input unit change the value of the table to 1. And then PLC checking that, okay, this is 1. So if it is 1, then output also should be 1 according to user project. And output unit checking the table as well. And if there is a signal, if checking if it is 1, if it is true, then passing the signal, and the relay is on. So this is the simple idea between input unit and output unit of the PLC. Okay, so according to code you wrote over here, storing in the table and checking the table constantly in a cycle time. Okay, so let's have a look to wiring. So here you can see the PLC AS218RX, but we have PX, I guess. So it is the wrong image, but more or less same. So we can talk about the same idea. So here there is an analog input output on the left hand side, and right hand side digital input and output. And this is the input part and this is the output part. So here you can see the common port of the input and common port of the output. Okay. So for the for the PLC, if you remember, it's already defined. When you purchase the PLC, it's already defined. It is the PNP output or MPN output. So you cannot change afterwards. It is already defined from the factory. But for the input, it supports all. So you can make the wiring for MPN or PNP. But the thing is that there is one COM port, right? There is one common port over here. So if you want a wiring for the 0, which is MPN, then the rest has to be MPN as well. if you make a wiring for the PNP, then the rest has to be PNP. Okay, so you can make both, but has to be same for all. But for the out, you cannot change. It is NPN or PNP or relay, whatever. Here you can see an example of the PLC wiring. And here you can see the example of the sensor. Okay, so this is the photoelectric sensor I have right now. So this is the NPN output, and NPN output means that switching the minus sign, right? Minus signal. So here you can see the blue cable comes over here and switching the minus sign. And then black, there is a minus as well. And load is mounted between the positive and the minus sign. And here, from the sensor point of view, load means PLC. Okay, and at the bottom you can see the PLC wiring. Okay, so here there is a 24-volt DC power supply, and there is a switching part which is sensor in that matter, and there is a common port of the PLC, and there is an input of the PLC. So we said that again, sorry, let me open the pointer options. Yeah, so we said that, okay, this is the minus sign. So minus sign comes over here to the input, and then we have to wire plus sign of the power supply to the COM port. So it is how NPN wired. Okay, so let me show output as well. Then we will make an example. So for the output, we say that it is NPN or PNP already defined. So here at the top, you can see the NPN wiring and PNP wiring. So same idea, NPN is switching the minus sign. So that's why you are supplying the COM port to minus. Then switching over here, and then here also there is a minus sign, and you are wiring load between minus and the positive. Same idea. This time it's PNP switching the plus sign, so that's why you are supplying the plus sign to the COM port, switching the plus sign over here, and from out there is a plus, and you are mounting your load between plus and the minus. Okay, so this is how it is wired. So let me make a quick example. Over here, share the camera. Yes. Okay, so here you can see the camera. So here I have a sensor. Okay, so this is PSRR3 Delta sensor, photoelectric sensor. Okay, here we have 3 cable. Brown and blue is the power of the sensor, and the black is the signal, and it is NPN, so it is minus sign, right? So yeah, actually it is 24 volt, won't be a problem. So I'll make the wiring directly over here. Okay, so yeah, this is the minus sign we set. So I'll make the wiring to over here, the black cable area. Okay. So it is just a laboratory part, so that's why I'm just making quickly. Okay, so, and this is the plus sign. Okay, I will wire this one later on. So yeah, this is the signal, right? So it will come to the digital input area. So here there is a digital input. Let's use first one, 0.0. So the second one, the first one is the COM port. So I mount this one to here. Okay. So yeah, and this is the plus sign we set. So I also make the wiring for the plus sign. Okay, so not finished what we have done so far. So we supply the power of the sensor simply. We also connect to the signal. Okay, so this is NPN. Then we have to make the wiring for the plus to the COM port. Okay, so here. Yes, so this is the COM port, and also it goes to power supply 24 volt. Yes. Yeah. So right now, here you can see on the left-hand side, there is a LED, if there is a signal or not to check. So here, I don't know if it's clear or not, but yeah. But I can say that here on the 0.0, I can see the LED. Hopefully you can also see. So what we have done, we make a NPN wiring for the digital input. Okay. Yeah, I try to simulate. So for the online training, actually it is the best thing we can do. Hopefully it was clear. Let me turn back to the slides. So actually I make this wiring and I see directly in the PLC input. Or I can also show here inside the PLC project. Let me connect. Compiling. Here we add a C program inside, so that's why there is another bar for C compilation. So this is the part C. It compiled the C program and then generate the test bin file and then store there. So I mean, ISPsoft also can build, no problem. Wait a second. Let me delete this one. Okay. Let's check system information if there is connection. Yes, there is connection. Okay. So what I have done, okay, you create your project. You have to transfer your project to PLC, to hardware. Okay. Because it is not this, I mean, it is working offline right now. So it is not synchronized. So you have to synchronize first. So you simply need to transfer to PLC. Download means that from ISPsoft to PLC, upload from PLC to ISPsoft. So here you need to download and asking you which part you would like to download to PLC. Here you can disable the program, but it doesn't mean that PLC cannot execute the program. No, actually PLC can read object code only. So the program you wrote inside the ISPsoft is converting to the object code, and the PLC execute the object code only. So this program is for just storing the PLC program inside, okay? So if you don't transfer the program to the PLC, then it is not possible to upload because there is no source code, okay? But if you would like to upload PLC project from another ISPsoft, then you have to download program as well, okay? Source project as well. So I click to source project too, and then transfer, and then yes. Okay, so here you can see in the status, they are green. So it means that it's okay. So what I'm gonna do right now, okay, I go to online and then make it run. Okay, and there is an error, just a second. Okay, here you can see the status of the CPU, and here in stop mode, and there is an error. Okay, so how to check the error, which error we have? It is just an indication, so there is not much information. So in order to check the error, you have to go to PLC and system log. And inside the system log, you can see all the error logs you have. The actual arrangement of I/O modules is not consistent with the setting. I guess we download the hardware config, but it says that it is not Same. Okay, so what we need to do, we need to download hardware config too. So let's go there. Okay, so it's already open. So I will download it. Yes, download everything. Okay, and close. And online mode. Okay, everything is green. So should be okay. And here, yeah, here it is shown stop and there is no error. And make it run. Yes, it is run right now and there is no error. So it means that my software in the ISP soft and the hardware is okay. There is no issue anymore. So here is, we said that this is the area that we write our own code, but there is also monitor table, which is quite handy to check the memory area that we talk about. So here what I did, right click and new and double click to monitor table and then double right, wait a second. Wait a second, it's not open. Ah, sorry, it is open, but here, yeah, okay. When you double click, it shows that, okay, which address you would like to check. Okay, so we say that it is x 0.0, right? So see, it is on right now. So when I move to the sensor out, then no signal. Now there is signal. So here we can see the physical input to PLC. So as I said, this is the monitor table. We check that the status of the variables. So for instance, I can create another one. So let's say for the output, I can control as a word. So if I type like this, it means that it is channel, okay? But with the .0, it is bit control, okay? So here I can control as a word as well. So in order to set, for instance, first and second input, then I need to change value to 3, okay? So you can also see the binary setting. So I want to enable 1, 2, 3, this 4, then 15, value 15. So when I set 15, okay, so actually I can see over here, but yeah, let me also show for you. Here, see, you can see the signal, there is signal, the output. So yeah, monitor table is quite handy to check the status of the input output or the memory area. Okay, so it was a thing I want to demonstrate. Next topic is we talk about the digital input output. The next topic is analog I/O. So we have analog I/O modules. For instance, AS06XA we have already right now here, and also PLC is a built-in I/O as well. So here the critical part is that output range or input range. I mean, how you would like to use as a voltage or as a current. So right now I only copy the voltage, but there is also for the current. So according to output range, there is a conversion range. It is kind of resolution of the analog signal. Okay, so if you would like to use between 0 to 10 volt, then the resolution is 32,000. Okay, and here on the left hand side you can see the wiring. See, this is what I mentioned for 06XA needs additional 24 volt DC power supply. Okay, if you don't wire this one, then there is an error on the module. After supply this one, then possible to use these input and outputs. Okay, yeah. So right now I don't have any analog output module, or I don't have any source for analog output. But what we can do, we can still use the voltage input for instance. So what is saying that for the voltage input, make wiring to the plus sign and the minus sign. And I can use, as I said, there is a built-in analog output on the on the PLC. So I can generate the output, analog output of the PLC, and then wire to the analog input. Okay. But yeah, first let me show you how to adjust the setting. So again, on the hardware config, I showed it before, but yeah, let me show it again. So this is how it is used. So when you double click the CPU, there is a built-in analog input to output. So voltage is already defined, minus 10 to 10 volt. Okay, it's possible to use right now. And the data exchange is, sorry, for the PX exchange area is for the analog output SR172. So this is the address that we control the output, analog output. Okay. So I will use the analog output 1, and I will make the wiring to here XA channel input 1. So for the channel input, let me see if it's already defined. Mode setting, yes, it is 010 volt. Okay, so it's working 010 volt, and the address is for the input 28002. And as you see, it covers double word because the resolution is quite high, 32,000 we said. So it is not possible for one word. So that's why I cover 2 words. Okay. So what I'm gonna do, I'll make the wiring then we will see inside the project. So let me again share my camera quickly. Okay, hopefully, yes. Okay, so this is the analog I/O module of the PLC, and this is the additional 06XA analog module. So what I'm gonna do, I will get the analog output from the module, from the PLC. So here you cannot see, but yeah, I'll make it quick. So voltage output 1, so I'll wire to red cable. Okay, and then module voltage input. Okay. Yes. And then there is a minus AG from CPU output, analog output to module input. Third one is the minus. Okay, so we make the wiring. So that's all. So I use PLC output, analog output to module input. So go to screen 2. Yes, here we will control the analog output and monitor the analog input. So what we said that double click again to check the address. Here, analog output SR172. Okay, so here I will add SR172. Okay, so this is resolution is 2000 only. So let me show you as well. Inside the product specification, AS200 analog input output specification. So here you can see for the analog output, minus plus 10 volt is only between 0 to 2000, minus 2000 to 2000, and SR172. So one word is enough. And for the analog, again, double click, channel 1, 28002. So I come over here. Okay, so I add both and I need to go online. So right now it was offline. So here you can see it is offline. So I click to online. Then yes, it is running right now. It is almost zero, we can say. So let's generate 10 volt. For 10 volt, I need to send 2000, right? I will explain this one. So here I sent the 10 volt, and here you can see that 10, almost 10.0, we can say. And the reason is that here inside the hardware config of the module, there is a mode setting. Sorry, where is it? Calibration format. Sorry, yeah, there is a format here. Here you can choose how you would like to use input as a float or integer. Okay, so it is right now chosen as a float, and it is between 0 to 10. Okay, so that's why we are seeing here as a float 10. Or if you use as a default setting, then you will see that it is 32,000 over there. Okay, so let's generate 5 volt, for instance. So 1000. Here you can see almost 5 volt. Yeah, there is no isolation, and my cable is just a cable, no grounding. So there is a loss for sure, but it is almost 5 volt. So here you can see after complete the wiring, you can control from the system flex. But what you need to do, you need to check the manual or hardware config to find the address. And the resolution is important as well. Okay, it was the analog part that I would like to show. So let's talk about the high-speed input as well. But I will not demonstrate this because we are running out of time. So PLC also supports high-speed input, especially for encoder application. So here you can see that, for instance, for the AS200, the one I have, supports up to 200 kilohertz frequency. Okay, so for sure you have to check the value of the hardware what you can mount. If you need more than 200 kilohertz, then you have to get a module, high speed module, or there are some other AS300, for instance, it supports up to 4 megahertz. Okay, so yeah, you can use any of them, these inputs, but up to 200 kilohertz. And here you can see that for the high speed counter, we use the counter instruction. It is 32-bit counter and including the high speed counter as well. So here on the left hand side you can see. So for the high speed counter, if you'd like to use high speed counter, then you have to use address HC200 and the others. Okay, then you can make the wiring and then it works properly. So for this one, we have a tool inside the ISPsoft. Let me show you that one quickly. So we said that we need to use D counter, right? So I came over here and typed the D counter directly. So yeah, let me move this one. Oh, okay. Okay, here you need to get the API selection and D counter, all type. Yes. So after inserted here, then double click. So there is a tool helping you to adjusting. Okay. So here inside the high speed, you can choose that. Okay, I have a one phase one input, one phase two input. So if it is encoder, it is two phase two input, for instance. Then saying to okay, then use HC202 and the wire, the encoder A signal to 00, B signal to 01. You can also see over here. And the counter mode and the maximum input frequency, so reset input. So this is kind of overview. So just keep in mind after insert the DCNT, double counter you can also call, then double click, so you can adjust the high speed counter as well. Okay, we talk about this one. So high-speed output also possible for the PLC. We have a module and also built-in I/O. We say that there is in the CPU. For instance, the one I have can supply up to, if it is resistance, up to 200 kilohertz. Okay, so these are the instructions to generate the pulse output. So you can see the differences, that high-speed pulse output without ramp up down, with ramp up down, etc. So there are many, but yeah, for now not possible to demonstrate. But yeah, we have many instructions, so you can check the AS instruction manual. Okay, before success stories, so we talk about mostly about the hardware thing. So how about the programming? Let's write some code. At least we will complete this part. Okay, so let me delete this one. So this is the ladle diagram interface. So here you can put the contact after you get. So contact, put the parallel or serial, etc. Or you can directly type, and then there is an instruction bar over here. Okay. So if you know the shortcuts, for instance, for the actually it's the instruction list. For the contact, it is LD. Okay, LD, and then address of the auxiliary input or physical input. So what I did, I put LDM3. So it insert as a serial. Okay, so if I need a OR connection, then I will type OR M6. Okay, so or what I can do, I can choose this one and this one. Okay, so yeah, you can use these tools, or with the shortcuts on keyboard, you can define your conditions. Okay, and there is also normally open, normally close selection. So this is normally open right now. So when I click, I can change the type: normally close, rising trigger, falling trigger. Rising trigger execute once, falling trigger execute once, but only rising edge only from false to true, falling edge from falling edge from true to false, and execute once only. Okay, so normally close. Or what is the shortcut of the normally close? So LDI M5, for instance. So here M5 is a normally close, it's inserted. Where we can see the list of these shortcuts. Here there is a PLC instruction reference, so go to there. So when you open the instruction, here inside the basic instructions, you can see that LD, contact A normally open, normally close, serial, parallel, parallel normally close. So here you can see the shortcuts. Okay. So and how about output? For the output, you can write out or directly only O. Okay, so for instance, Y 1.1. Okay. So if you are using channel X1, X or Y, then you have to define also the bit. But for the M, you don't need to define the bit, because this is only bit area. Okay, so you can use directly 0, 5, 6, whatever. But if you use as a Y1, for instance, there will be error. Why? Because this is a channel, so this is the word area. So see, right now what I did, I set the word, which is not possible. So we need to use compile, because when we type the project, it is not compiling constantly. Okay, so when you finish your project, then you have to go to compile and check your user project. See, for instance, there is an error because coil must be Boolean type. Okay, so like M4, okay, or 0.2. Okay, so this is the contact and output. How about instructions? What kind of instructions we have? So you can go to the AS instruction manual, or simply you can go again instruction. to check the instruction list over here. Okay, so these are the instructions we have. So you can see the float calculations, you can see the move, you can see the conversion from 32 to, yeah, there are many. So yeah, you need to check, depends on what you need. For instance, there is a timer over here. For instance, let's see the timer. So this is timer and 100 millisecond timer. Okay, so there are 3 operands: S1 timer number, S2 setting value of the timer. So yeah, you need to give a specific name. So S1 is the timer number, and S1 supports only data type TMR. Okay, so you cannot define a D area, for instance. You have to define T memory. For S2, you can assign a word or integer. Okay, let's make a quick test. So here, if you type directly, as I said, there is a tool. So we say that it is timer, right? So I write TMR and then click enter. So ISPsoft assigned for me. So here I need to assign an address. Let's say that T0 I want to use. And the set value is, I can directly type like 100. So if it is 100, yeah, let me explain that one so it will be easy. So this is 100 milliseconds, right? So it means that the value you wrote will multiply this value. So then 100 multiply 100, it means that 10 seconds only. Okay, so if you need to run 5 seconds only, then you have to write 50. Okay. So what we have done, let's make it normally open. So yeah, we put a contact M5, and then after 5 seconds, T0 is enabled. And put another one, for instance, and let's use T0. And I forgot the LD command. So when the T0 is enabled, let's enable a output by 0.1. Okay. And add another one, another timer, and let's call it timer 1. And let's set it 40. And let's reset the timer and restart again. So let's add a LDI, normally close, T1. So what I have done, normally open. Yes, what I have done, when I enable the M5, T1 is off. So that's why passing normally close. So timer starts to count. When it reaches to 5 seconds, then this is enabled, and this is also enabled. T1 is still offline and starting the count. And when it is on, T1 is on. And when the T1 is on, the signal is cut from the timer 0. So T0 is off, and also this is off, and T1 is also off. So starts again. So let's execute this one, for instance. So what I have done, I compiled first, then I said that go to online, and asking me that, okay, you said that go to online, but the PLC project inside the hardware and the software are different. Would you like to download? And I said, yes, download it. And I click source project as well. So it is downloading right now. And after we download, turn to the run state. This is important. And this is 5 seconds, 4 seconds. So when I click the set on, it starts to count. And when it reaches to 5 seconds, it is on. And after 4 seconds, it will be off again. And start it again. So what we have done, we made a simple blinker. So yeah, for now we use a constant value over here. But if you want to use, if you want to change this one during the user project, then we have to assign an address. For instance, D100 and D101. Okay, then we can change the value during the execution. What else I would like to show you? There is a command on the top of the contact. So you can define a contact command, start blinker. Okay, so first timer. So here assigning a command of the address. So M5 is start blinker. So it just makes simple for you. So when you assign, when you use T0 in another place, then it also shows the command as well. Okay, so it helps you to remind. And here there is a device command list. Here you can see all the commands, all the address that has a command. So for instance, we use for the T, right? So when I go to the here, says that T0 has a command. Okay, so you can see the address that has a command. M5 start blinker. So device command list listing you the addresses that has a command. Okay, so here you can also see some address which has a command. These are predefined system flags. That's why there is a S at the beginning. So these are predefined system flags. There are many and has a command also. So if something needed, you can also check over here and directly use from here as well. So yeah, for the high-speed counting modes, you have to check them. Okay, we talk about the command, that's fine. And also another way, we say that, okay, this is address-based working, right? So we can also say that we can use variable. So I don't want to think about the D101, but I want to keep it as a set value. So I want to use as a variable. So when instead of the address, when I type a unique name, it shows me that, okay, should be a symbol then. And the data type most probably word because used inside the timer. And here you can assign an address like D101, right? So when I clicked OK, so here on the upper part, you can see the variables here. So set value D101. But here again, you are thinking about the address. So you have to assign address. Or you can leave it empty. Then ISPsoft PLC assign it for you. Okay. So right now, it uses automatic addressing. But doesn't mean that there is no address. Still there is, but defined by PLC. So you don't have to care about the PLC address anymore. Okay, so right now what I have done, I don't use the address but variable. So for instance M5, instead of M5, let's say start blinker. Okay, so when I click to enter, asking me that okay, it should be a boolean because you're using the contact, and I click OK. Okay, so right now I can see the variable. So the variable listed inside the program called local variable. Okay, local variables means that can be reached inside the program created. So these variables belongs to starter program, so cannot reach from the program 0 or 1. So if I need to reach the variable created in the program 0 from the program 1, then I have to use them as a global variable. So global variable are created inside the main table. Okay, so I go over here, main table, and then double click. So here I define a variable, give a name, address, okay, automatic, but you have to assign, you have to define the type. And yes, so this is global variable anymore, right? So I go to the program 0, or later will be simple to see. So LD, let's put a contact. So here, when I click, I should see the, wait a second, let me compile. I guess there is a, okay, wait a second, there is an error. So when I compile, you can see the compile error. So also when you double click, it gets you to the place. So this is, for instance, yeah. inside the mail table, we call to training, and the data type is Word. So that's why I cannot see that. So I will set as a bool. Okay, then go to the program one. And here, see, I can see the global variable inside. Okay, and output, let's call just as simply. See, the color are the different. So this is this is different color because the reason is that it refers that this is comes from global variable. Okay, so you can also define the variable type from the color, and also here you can see that it is red. It means that there is nothing wrong. It just shows that it is not compiled yet. So when I click the compile, this red button goes, the red line go to the black. It means that it is compiled. It works well. Okay, so let me come back here, and also I can see the list of the main table here. Okay, so when you are creating local variable, you can also define them as global variable inside the local variable. So when I choose to define global, it goes to the main table directly. Okay, so what else? We talk about the device command. Let's have a look to use device report. So this is a tool. It shows that which variables you used. Okay. So when I click the device report, I can see on the right hand side which address I used inside the PLC project. Okay. So also I can see the overview of the, for instance, M memory area, M5, right? Yeah, M15, yeah. M15 is used. There is a mark here. It means that M15 is used. And here says that, okay, you used M15 before in program one. So when you are writing code, if you forget which address is empty or if you use that address before, then you can come to the device report to check if it is used or not. Okay, last thing, let's do the ST example. Then we will close. So this is the ST area. So as I said, if you are familiar, then you can directly type or you can get some sample over here. For instance, let's create a for loop. Okay. When I click the if, there is a sample over here. Let's make that if 20. Okay. If M20, I will do something. What I'm gonna do? Let's do the I don't know. Let's do factorial. Let's say. Okay. So I will create a factorial calculation. So for the factorial, what we need to do? We need a value and then decrease one by one, right? And then multiply them. So what I need a some internal variable like calculation result. Add a symbol. Okay. Given number, let's say, and it is double integer. Okay. And it goes to the main table, but it's okay, no problem. And let's create another one.
Ufuk?
Yes?
We have the questions here.
Ah, I didn't recognize it. Let me check. Is it possible to turn all output on by using a move instruction to move a decimal value? Example, move 15 by 2. Yeah, true. As we said, the output can be controlled as a channel. So yes, you can control all the channel with the move command. Yeah, it is possible. Yes. Is it possible to use auto address when communicating with HMI? No, unfortunately not, because HMI works based on address based. Unfortunately, so far we don't support it. So if you would like to communicate with HMI, you have to define address manually by yourself, and then use the same address on the HMI side. But hopefully in the future we will solve this. Okay, thank you, Justin. Okay, what we are doing, so result, let's go. And result is also double integer. And no global. And we need an auxiliary variable. Let's call it also double integer. Okay, so for the factorial, we need to make calculation with the 4, right? So this is the auxiliary variable I, start from 1 to where? To the input value. So what was the name of the input value? Given number we said. Okay, let me delete this one and put to here. Okay, so no need to address, but the type is double integer. Okay, so till given number and increase 1 by 1. And the solution will be result, right? Result will equal to result and multiply by I. Okay. So at the beginning, result is 1. So we have to also assign as a result is equal 1. Okay. And I is also 1, which is assigned here. So no need again. So what's gonna happen? Result is at the beginning is 1. So I is also 1. And multiply and then result is 1. Then increase the I2. So 2 multiply by 1, then result is 2 and I is 3. So multiply 2 and 3, 6 and increase I1. So it is the algorithm of the factorial, for instance. So let me compile. And this for loop works if M20 is on only. Okay. Let's see what we have done and if it works properly. So I transfer it. Okay, so right now it is not working because M20 is off. So I set it on, and then change to the given number to, for instance, where is it? Change present value to 5, for instance. Yes, we are doing over here wrong. Yeah, wait a second. So I did assign in a wrong spot. So I have to assign it here. Okay. So I changed the code. So I had to compile, and if everything's OK, then I need to download to PLC, and after download, we can go to online for debugging. Okay. So right now it is running, no error. So let me set M20 and change the present value to 5. So here the result is 120. So 6, 720. So yeah, it is working right now. So what we have done, we ran a factorial mathematical calculation inside the ST. So what I want to show afterwards, so you can see the result. Here at the bottom, you can see the scan time, right? So it is right now 2.8 milliseconds. And let's calculate the 100. Then scan time C already increased to 3.3 milliseconds. So 200, it is still increasing. So as you see, if you are using a for loop, it means that the execution time is increasing over here. The calculation, the code you wrote over here. So what's going here? Till get the result, the execution is turning around. Then the execution time of the scan time of the PLC is increasing. So what you need to do if you are using those kind of loops, you have to create a function block or you have to work it once only. Not you shouldn't enable it always. Okay, otherwise it's just keeping increase. And another key point that I would like to remind is that, see here, we say that, okay, calculate the 200 factorial, and the result is 0. Actually, it is not 0. It is calculating, but this is 32-bit PLC, so double word. So for 200 factorial, it is not fit on 2 words only. So it used 3 or 4 words, but not possible for PLC to store. So that's why it shows 0, but it doesn't mean error. Just keep in mind that there are limits on the data types, okay? So if you are using double integer, then you have limited to 32-bit. You cannot do a calculation over that. Okay, so it was a thing I would like to show you. And let me recap quickly. So we talk about the command list, use device hardware config, we talk task we talk about. Global sample, we talk about the main table and the local variables. Programs, we talk ladder SD. Device monitor, function block, we haven't demonstrated, but yeah, it is advanced, so maybe we will do in another training. And we talk about how to import C as well, so this tree is okay. And also here we talk about the communication setting. And here inside the PLC, how to check the log and system information, how to compile. So yes, we have a question, I guess. What is eCam editor? It is a good question. eCam editor is not for AS series. It is for AS500 series, I guess. We will release AS500, which is motion control EtherCAT base. Shouldn't be seen in AS200. I need to double check this part. eCam, no, there is a position table. Yes, inside the position planning, possible to use. But eCam is something new. I guess it is kind of missing. I need to clarify it. I'm not sure.
Ufuk,
Yes.
we have another question here.
What is eCam editor, right?
Yes.
Okay, yeah, I'm talking about that one. eCam editor is something new. I guess it is for AS500, not AS200. Okay. So yeah, from the hands-on part, that's all. There are just 2 success cases I would like to show, and then we will finish.